Hey, good morning or good afternoon or good evening, depending on where you are. Welcome to another edition of Coffee and Capture, Conversations on Intelligent Document Processing. How's that for my radio voice? We're going to do things a little bit differently today, so you're going to hear me ask Rebecca to change some slides. My hard drive apparently failed. And, just like computers, it decides to fail about 10 minutes before we go live. So I am doing this from my tablet. There's, Internet of Things devices these days. As long as you got something that can connect to the internet, you can do anything. I should have been doing this out on the golf course this morning. All right, so let's go ahead and go into the next slide and we'll introduce the topic. All right, so the quick topic for today is NLP, natural language processing, and how does it fit within intelligent capture or intelligent document processing? We get a lot of questions a lot of times where when we engage with prospective customers and existing customers, the topic of NLP comes into play. And oftentimes, I think that the intention is good, but it's actually bringing in a technology or trying to identify a technology solution before the actual requirements are even understood. So a lot of cases, and there's also some misunderstanding around NLP because, gosh, I mean, if the industry isn't too loaded with abbreviations and three-letter acronyms, I don't know what is. So we're going to talk about natural language processing, what it is, how does it fit in there, and everything like that. So let's go to the next slide. Okay, what is NLP? Normally I'd like to build out these slides, but there it is all for you. 1, 2, and 3. So natural language processing is really about deconstructing text. Text, whether it's a text from a phone or social media or text within a document, and that's what we're talking about today is text within a document, whether that document is born digital, like a Word document or something converted into a PDF, or if it's a document that's scanned and then subsequently OCR'd so we can get to the text. But it's really about working with the text to try to understand what's going on, understand themes or concepts, and it's all about being able to come up with some sort of information within a larger body of text. Now, NLP is not a thing unto itself. There's a number of different types of things that are involved under the NLP umbrella. So I'll get into some of the other things, but it typically involves 3 different steps along the way. The first one is, and one of the things that I do want to bring up is that when we're talking about NLP types of, or applying NLP, we're really trying to apply it to paragraphs or pages worth of text where there's really no fields to think of. We're trying to extract information within, this kind of verbose type of language. So the first one is word and sentence segmentation. In order to really work with text, you have to understand what a sentence is, when one sentence starts and when one ends, and definitely what the sentence is constituted up with. So that's words. So the first thing we want to do is break those sentences and words up, and then we can go to the next stage, which is called parts of speech tagging or post. And what this does is it labels or tags each word grammatically so that what it ends up doing is it identifies the nouns. It can identify adverbs and adjectives, all those types of necessary grammatical types of constructs that are needed to be able to put things into place and to understand something. And then the next piece of it is called what they call phrase chunking. And what that means is we're looking at sentences, larger things. So we're taking the words, we've got the tags of what each words are within a grammatical structure, and now we're looking at it at a more holistic level at sentences and multiple sentences to be able to understand how these sentences relate to each other. And so that's called phrase chunking. But the big deal here is we're not done. If you go in Canvas and look up NLP toolkits and things like that, most of the time what you're going to be looking at are the toolkits that do these word and sentence segmentation, the post stuff, and the phrase chunking. ultimately, all of this is deconstructing text so that you can feed it into a machine learning algorithm, and more, these are neural networks, and they're deep learning neural networks that are used to be able to take this information as input and then identify specific things. So none of this happens magically. It's always a prerequisite to analyze the text and then feed it into a machine learning system where you're aiding it and it's trying to find specific things that you're looking for. So let's go to the next slide. So here's an example. This is an example of input text and how it's converted. And this is text from a promissory note, typically involved or almost always involved in a mortgage process. So in this case, we're taking the phrase or the sentences, borrower promised to pay. That's basically a section item. And then you've got this, in return for a loan that I have received, I promise to pay US $200,000. So once we go, we take that text, we can, in the part of the process, we've got those sentences and words. Now we're going to go to the part of speech tagging, and this is what it looks like as an example. So you can see here, each word has a tag, and that's shown in red, where it's identifying, and this is all abbreviations for different grammatical structures. So I'm not going to go into actually, I'm not going to go into any one and explain it, but this is what it looks like. So what you've got is, you've got the text and you've got the tagging. And what all this tagging is meant to do is that this is information that a machine learning or neural network will utilize to be able to derive certain types of meaning. And then we've got the phrase chunk. So now we can understand that borrower promised to pay is a phrase, and then in return for a loan that I have received, I promise to pay, and then you can go on and so on and so forth. So all of this information is the prerequisite knowledge or input data that we need to feed into a machine learning algorithm. What the machine learning algorithm does is it takes this information along with, so each example of these things has to be provided with an example of what we're looking for. So in this case, if the task is, I want to be able to identify how much the borrower is borrowing, the amount, then I might tag the 200,000 as a value. I might also tag some other things like I promise to pay as key indicators of that there's going to be a value for the loan. And then all of this information, it's called ground truth information, is utilized by the neural networks to be able to identify and infer different types of rule sets and things that will indicate very reliably how to find that borrowed amount. So let's go to the next slide. So why is NLP needed in capture? And I kind of alluded to this just previously, is that in intelligent capture, from probably day one, after we went from imaging and full text OCRs to aid search, was we were really looking for specific data on a document or a page. And the first type of way we could look for data is to tell the system where to find the data in terms of X and Y coordinates, otherwise known as zones. And that was for structured information. And then we moved into this semi-structured world where we're processing things like explanation of benefits and invoices and bills of lading, all of which have similar information, but it's laid out in a different location. But we can use things like tags, like the labels of this information, because all of this is essentially kind of like a form. If I find invoice number, I'm certainly going to find a phrase or something that says invoice, # or invoice NO period, that is a clue to helping me find that information. So we call those tag value pairs. But in cases where we're dealing with things like agreements or contracts and longer form types of text, where there isn't any available structure, where we can't always rely on specific locations or presence of these tags to be able to find clues, to be able to use clues to find this information, that's where NLP comes into play, because NLP can help find this information in a more grammatical sense. So it's the subjects, finding subjects of a sentence, or the nouns of a sentence, or in some cases adjectives. We can use those as clues and then train a neural network to be able to find the information we're looking for. So NLP solves that problem by helping to provide yet more information, more clues and hints within text that typical intelligent capture doesn't bring to bear. So let's go to the next slide. So here's another example. This is within healthcare, and I want to say this is actually from a drug form or from a study form where what we want to do is we want to find, we might want to find the drug specifically involved, the dose involved, and the dates. Now, you might be able to use somewhat reliably pattern matching, such as find things that look like date formats, or use clues like milligrams to identify, what the dose might be. But in some cases, those can be very clumsy, or they may require a significant amount of analysis and hand coding rules to be able to do that. But another way we can do this is we can, again, parse this text in a grammatical sense to identify, the subjects, the objects, nouns, and things like that. We can easily train a neural network if we label this sentence, for instance, that we're looking for 50, we're looking for the value of 50, or we're looking for the value 9th of April 2015, or looking for the name naltrexone. We can code all this along with the grammatical information and feed it into a deep learning neural network, and it will automatically use all this information to identify the most reliable way to locate and extract this information. So here, again, you've got this example of the tags data set, and then once we feed that into a system, and again, we're going to feed a lot of this data. We're not going to just provide one example, but typically several 100,000 examples, because we're dealing with deep learning neural networks and they're very data hungry. But ultimately, you get a very forgiving learned model that has a more exhaustive set of rules to be able to find and adapt to this type of text-heavy type of information to be able to reliably extract information. So let's go to the next slide. So always the upshot. So NLP, natural language processing, especially with an intelligent capture, this is really should only be used where traditional methods can't work well. Either, we're not dealing with structured information or semi-structured documents. I would always say you should try, though. You should really try to analyze the information, because these traditional methods are typically much more precise. So they may be brittle if you're dealing with a high amount of variance within text, but if you can identify patterns where you can reliably locate this information either by quadrants of a page or by tags or things like that, always try that first. And I would actually always use machine learning to do it still, but it's more of a precise mechanism. But when we're dealing with agreements and things, and you're trying to find like property boundaries or locations or things like that, where the variance of how the wording of these agreements it's just way too much or it's too vague, that's when you want to use natural language processing toolkits to precondition the text before you send it into a training exercise. So it's text-heavy types of documents that are best used for this. Now, one of the things that we often encounter is this belief that natural language processing is kind of like the silver bullet. So, if we've got really complex documents, then we'll just throw natural language processing on it, and all will be well. And this couldn't be further from the truth. So, just like any other type of data automation task, you need to be very specific on the scope and the requirements. So, if you've got a trained model using natural language processing on a mortgage type of agreement, it will not do well at all on an agreement that might involve insurance related types of terms or terminology. So you always have to train these systems on the specific data sets for which you want to operate on and automate. You can't take NLP, a learned model that's on one document set, and use it on another. We're really familiar with natural language processing or natural language understanding when we talk to our phones or our connected devices. And I can tell you that every sentence that you utter that it actually ends up understanding has been trained on significant amounts of those specific sentences and outcomes. So it's not a case where you can just train a computer to understand language and it's just going to understand everything. We're not to the level of positronic brains like Data and in Star Trek and whatnot. So again, anytime you're going to be using any kind of automation against document-based information, whether it's a traditional method or these more modern takes on natural language processing, you always have to have a nice, good size input data set. You have to condition it well, using these toolkits to be able to parse and tag these documents, and then train the heck out of it. And that's the way you get to good performance. And I think that is it for these slides. Again, it was just a little nugget of information, leaving us about 14 minutes for any kinds of question or answers from you all, or from Rebecca, who might have some other types of things. You can ask me anything now.
Yeah, Greg, I was just wondering how much training it actually takes. I know that it probably depends, but can you give us just a sense of what it takes for different types of examples?
Yeah, and can you still hear me? Okay.
Yeah.
Okay, great. So, yeah, you're right. It's always the dreaded "it depends," but I can tell you that in most cases, natural language processing does a pretty good job at detecting things like sentiments, or is this good or bad, or positive or negative. Think of things like Amazon reviews, where you can detect different types of language and what it's measured against and whatnot. And the performance is pretty reasonable when you get to requests or requirements where you're actually trying to pull out terms of a contract. I think the best cases these days with even large training sets, and when I say large training sets, this is well over 100,000 training sets, is just shy, just above 50%. Now, what that means is you can automate 50% of contract analysis, and with a highly reliable outcome. So if you're looking for contract beginning and end dates and who the parties are and things like that, it's actually quite significant performance improvement to be able to remove 50% of all that type of work and let it go straight through. But the complexity involved with being able to find and target this information within a 1, 2, 3, 4, 20 pages of a document is a really complex endeavor. So the levels of precision and performance, when you compare them against traditional methods like using tag value pairs, or regardless of how you're using machine learning, all the rules and available constructs that you have to be able to place on it to derive and produce really good results, it just isn't there yet. Now, so I would say sample sets. In most organizations, what you're seeing with unstructured information is you've got vendors that are pre-training and focusing on specific use cases. I mentioned contract analytics is one of them, and they'll pull and curate data sets that are pretty significant to be able to pre-train the software so that you can use it more or less out of the box. But when you're talking about bespoke/custom projects where there isn't an ability to pre-train, then you're dealing with a pretty significant data preparation and data science type of effort.
Thank you.
No other questions?
That's all. Yeah.
Okay. As always, feel free, if a question pops up about this topic or others, feel free to send an email where we will answer questions as we get them. We may use some of these questions to spawn another session on a different topic. So we're all ears in terms of being able to answer questions that you have on any range of topics involving intelligent capture. So with that said, thank you for attending, and we'll see you again next time.
Thanks. See you in 2 weeks. Thanks, Greg.